Okay, class, this is the third part of our probability chapter 5, and basically we're going to look at some more advanced results. First item here is what's called the general multiplication rule, and you'll note in this statement probability of A and B and C. If I just cover the and C, then we have probability of A times probability of B given A. That's our old one. This can therefore be extended to more than two events as such. Note the notation, this bar here is given events both A and B. Generalizing, this is probability of A1 and A2 and A3 and so on. It doesn't look real great, but the idea is it can be generalized. Now, the one place we're really going to use it is in this next result, which is kind of a nice, interesting result. Can be used in some cases. It's called the law of total probability. And basically, this is it. The probability of event A, here it is the sum of these separate events. Now, it looks a little weird. How would you use that? We're going to do an example. But before we do, I want to give the proof, which will give insight behind it. And let me just say, all students are welcome. Math majors, I want you to follow this. If you're not a math major, feel free to skip this part. Okay, key thing is the following diagram. I'm just going to draw a big box, which is going to be the event all of B. But I want to distinguish between, let's say, a B1, and let's make a B2, B3, and so on up through event Bn. Okay, that's B divided into n parts. Now, let's flip a different color here. We now have event A, which I'm going to draw as intersecting all these B's. So this red shape here is event A. And this piece that's just inside of B1 is, we're going to call that A1. Next one we're going to call it A2, A3, all the way up through AN, and so on. So I have these NAs. Now that lays out all the parts. If you read this line right here, then you'll notice that these math symbols give us what I have just drawn. And so I leave that for you to take a look at. Here's the proof. We start off with probability of A is the probability of the union of all n parts of A. We can visibly see that they're mutually exclusive. When we combine them all, it gives us exactly A, and so the probability of both should be the same. Now, the union of A's probabilistically is the sum of the A's, and since they're mutually exclusive, we don't have to use the OR rule with subtraction. Okay, so we just add all the probability of the AI's together. Now, here is a key piece. Notice the probability of AI is equal to the probability of A intersect BI. Okay, what does that mean? Well, let's consider this first box right here. This is B1. If I take B1 and I intersect it with A, where A is the whole red oval, then I get just shade it in with yellow here. I get just this part here, okay, which is exactly A1. And so indeed, probability of A1 is probability of the B1 region intersected with AI, which is A and BI. Good. Okay, well now we have the AND. Keep in mind that's an AND right there. We already know how to work with AND. It gives us our good old rule, probability of A and B is equal to the probability of A times probability of B given A. Okay, keeping that in mind, boom, I've just applied it right here, except note that the A and B are in flip position. That's fine. We're done. Probability of A equals this guy. That's the law of total probability. And that gives some insight into how, in the event that we don't know this whole inside region, we can chop it into parts, and if we have information about each part, we can, using this formula, find the probability of the whole. As an example, we will consider a chain of video stores. They've got 3 different brands of DVD players. Okay. Now, 50% are brand 1, 30% are brand 2, 20% are brand 3. Okay, great. Each one gets a 1-year warranty on parts and labor. Awesome. Furthermore, we have 25% of brand 1 DVD players require warranty repair work, whereas brand 2 requires 20%, brand 3 requires 10%. Okay. Now, the big question is, what's the probability that if you buy a brand 1 DVD player, you're going to need warranty repair work? That's a very relevant question, which you might want to know the answer to before you make your decision as to which DVD player you buy. Now, I have this here in 3 lines, setup notation. This is perhaps the most difficult part of the whole problem. So let's walk through it here. Where do we put our A's and our B's? Which symbol you use isn't critical, but you want to just be consistent and slowly work it through. So I'm going to use BI is purchase brand I, and we of course have I equals 1, 2, and 3. And then A is going to be DVD player needs warranty repair. That's the thing that we're looking at. So if you go down to the question again, brand 1 DVD player while under warranty, this is the statement. Probability of B1 and A. So that's probability of brand 1 and under warranty. Okay, so you can translate that into this. That gives us a signal for what kind of notation we want. So, what's the probability that we're brand 1? Well, we have that information from the problem. That's 50%. Okay, 2 is 30%, 3 is 20%. Now, let's read this next line. It is known that 25% of brand 1 DVD players require warranty repair work. How do we do that? Well, given that we are brand 1, the probability we require warranty repair is 25%. And similar for the other 2. So that's the key. With the notation, everything else follows. Okay. So let's do part B here. Probability of B1 and A. That's going to be probability of A given B1 times probability of B1, which we have. We have both of these 2 parts. So A given B1 is 25%. B1 is 50%. So that gives us 0.125. Okay. 12.5% chance that the random purchaser needs DVD repair. Okay. Now we're going to ask the next question. What's the probability that a randomly selected purchaser has a DVD player that will need repair while under warranty? That is, what's the probability that anybody needs a warranty repair, period? So that's probability of A alone. Okay. This is where our law of total probability is going to come in. And employing the law of total probability, we have the three parts. So the probability of A1 part is probability of A given B1 times probability of B1. Okay. That covers brand 1 players. So just taking a look here, that would be equivalent to this first component. We're going to need the next two components. So the formula, I'm going to add those three parts. So the summation, we need A given B2 times probability B2 plus probability A given B3 times probability of B3. Now it's just a matter of plugging in. So 0.25 times 0.5 plus 0.2 times 0.3 plus 0.1 times 0.2. Okay. Final result is 0.205. Okay, now I want to move on to finishing this example. Question 2. If a customer returns to the store with a DVD player that needs warranty repair work, what is the probability that it's a brand 1 DVD player? Now let's be careful. We write that probability of B1 given A. Okay. What we had before was probability of A given B1. That is, probability of needing warranty repair given that it was a brand 1. Those we had. But how can we use what we had to find this question? Probability that I want, given that somebody comes in, that it's a brand 1 player. Okay, that requires basically flipping these probabilities, which you can't normally do, except that there is a special theorem. It's called Bayes' theorem. You may have heard of this. Just in passing, I want to note that Thomas Bayes was a reverend, and he was a Presbyterian minister, but he was also a mathematician, and he developed this theorem that's used very widely today. In fact, we won't go into it in this class, but some have gone so far as to say that this 21st century is the year of the Bayesians in the statistics world. Okay. Now, here's the theorem. It's stated very simply. The probability of BI given A is this guy right here. Now, I want to note that the denominator probability of A is just this, which is the law of total probability. And so typically you'll see the theorem written in this form. And in passing, I want to note that this is the discrete version. There is also a continuous version, which is going to use integrals. Okay, that said, the proof is elementary. I think you can all follow this. We've got probability of two events, A and B. We've got a subscript on the B, no problem. That's probability of A given BI times probability of BI. It's my multiplication rule. Now let's just take this A and B and flip them. Just switch them around. Probability of BI and A, well, that's probability of BI given A times probability of A. But these two are the same, right? Yes, they are. So let's set them equal to each other. And I get these two expressions equal. Now, I'm going to divide both sides by the probability of A, because I want to get rid of that. So I put the probability of A over here, and we're done. That's the result. Okay. Using this result, then, I can now answer the question. if the customer returns to the store with the DVD player, what's the probability that it's brand 1? Well, here we go. I've got, just plugging in directly into the theorem, we can say probability of B1 given A is going to be probability of A given B1 times probability of B1 all over probability of A. Now, we painstakingly found this part, okay, using the law of total probability. If we didn't, we'd have more work to do. But since we did, we've got these two probabilities familiar from last time. We're going to divide by that 0.205 that we found on the law of total probability, and we now get 0.61. So what this means is somebody comes into the store, they say, hey, I need repair on my DVD player, then boom, before we look at the player, what's the probability that it's a brand 1? Whoa, it's 61%. That's very different than the 25% of brand 1 players that need servicing. And that covers Bayes' theorem. We've got an extra example in here on breast cancer that you're welcome to read and fill in. The result, I'll just give you the final answer is going to be 0.07477 is what you should come up with. That's instructive. Okay, Lord bless you. We'll see you in class.